Hello, and welcome to another lesson from Level Up Mathematics. Today we'll be exploring the key attributes or features of functions. Many of the terms you're going to see today you'll already know from previous grades. Now, in this course, we'll study all type of functions. While each function will have a different shape and characteristics, it's very important that you familiarize yourself with some important vocabulary that all functions share. Much of the vocabulary will already be familiar to you from previous courses. So in example 1, we have the graph of y equals f of x is shown graph to the right. Answer the questions based on the graph. In part A, they want you to state the x-intercepts for the function. So remember, in your coordinate plane, your x-axis is your horizontal axis, and your x-intercepts occur wherever the function crosses the x-axis. So it comes up, crosses the x-axis here, then goes around, comes down, crosses here, goes down, and comes back up and crosses it here. So you're going to have 3 x-intercepts. So we have 1, 2, -3, 0, -1, 0, and 1, 2, and 3, 0. What is the alternative name that we give x-intercepts when we're talking about functions? Hopefully you remember that alternative name are the zeros of the function. All right? Evaluate f of -4. So what I want to do is I want to start at 0, 0 and go left 4, and then I'll count down to where I hit the function. So 1, 2, 3, 4 to the left, and then count down until I hit the function. 1, 2, 3, 4. So f of -4 is equal to -4. All right, for what values of x does f of x equal 0? Well, remember, f of x is the same thing as y. So we want to know, when does y equal 0? Look back at problem A. Notice that in our x-intercepts, the y value equaled 0 3 times. Y was equal to 0 at -3, -1, and +3. That's when our function was equal to 0. All right, next question. Let me erase some of these dots here so that we can look at our next question. Over the interval -2 to 1.5, is the function f of x increasing or decreasing? So they're wanting you to look at this interval from when x is -2 to when x is 1.5. On this interval, is the function increasing or decreasing? Well, hopefully you said that the function is decreasing. The y values are getting smaller on that area of the graph. All right. All right, what is the relative minimum of this graph? We can't find the absolute minimum because it continues downward to negative infinity. But we do have a relative minimum that occurs right here at the relative minimum is -17, and it occurs at x equals 1.5. The relative maximum is right up here, and it is 5, and it occurs at x equals -2. All right, example 2. The graph of a function f of x is shown below. Use the graph to answer the questions. The absolute maximum of this graph occurs right here. So 1, 2, that's -2, comma, 1, 2, 3, 4, 4. So the absolute maximum of the graph is 4, and it occurs at x equals -2. The relative minimum of the graph is right here, 1, 2, 3, 4, and this is the point 4, comma, 1, 2, 3, 4, 5, -5. So the relative minimum is -5, and it occurs at x equals 4. State the domain and range in interval notation. All right, so for my domain, my leftmost point is negative infinity over here. My rightmost point is 4 comma negative 5. So I'm looking at my x values. I'm going from negative infinity to positive 4. Negative infinity to positive 4. So the domain, negative infinity, and 4 is filled in, so I'll use a bracket there. For the range, the lowest y value, let me highlight this in pink on the graph, is negative infinity. And the largest y value on the graph is up here at 4. So my range would also be negative infinity to positive 4. All right. Example 3, state the increasing and decreasing intervals for the function shown below. Now I'm going to highlight the increasing first. This function is increasing from here to here and from here to here. So to write this in our notation, we're just using, let me write this down for you, use the x values to describe increasing and decreasing intervals. So our x values, we're going from negative infinity to negative 2, and I'll use the union symbol here, 1.5 to positive infinity. So there's your increasing intervals. Now let me use a different color for D. The function is decreasing just in this part of the graph. So we're only going to have one decreasing interval, and that would be from negative 2 to 1.5. That's our decreasing interval. All right. Problem B, our increasing interval. So in this function, we only have one increasing interval, and that is from, I'm just using my x values, so negative 3 to 1, 2, 3, 4 to 5. It's increasing from negative 3 to 5. Now for decreasing, we're decreasing from here to here and here to here. So we're going to have two decreasing intervals. So 1, 2, 3, 4, 5, 6. So negative 7 to right here, 1, 2, 3, to negative 3. And from 1, 2, 3, 4, from 5, 6 to 7. So those are our decreasing intervals. Right? Example 4. Use the given graphs to answer the questions. Question A. For what intervals of x is f of x less than 0? Now remember, f of x is the same thing as y. So this is asking where is y negative? Where is y less than 0, or where is y negative? So let me shade the portion of the graph of this function that's negative from here to here. So you're just going to give your x values. So 1, 2, from negative 3 to 1, 2. The function is negative. Okay. Now I used parentheses instead of brackets because it was just less than 0, not equal to 0. For problem B, it wants to know for what intervals of x is f of x or y greater than or equal to 0. In other words, where are the y values positive? Where are the y values greater than or equal to 0? So let me highlight that on here. The y values are greater than or equal to 0 just in this portion of the graph. All right? For this portion, the y values are negative, and for this portion, the y values are negative. So I'm going to list my x values here. 1, 2, 3, 4, 5, 6. Negative 6. 2, 1, 2, 3, 4. Now this time I used brackets because of this equal sign, because it did include where did the function equal 0. All right. Last example. The graph of y equals f of x is shown below. Give the interval where f is increasing. Well, I think we're increasing twice here, from here to here and from here to here. So remember you're going to list, let me reset. You're listing the x values when you're talking about increasing and decreasing intervals. So this x value was negative 4 to negative 2.1. It's increasing. And again, it's increasing from 1.8 to infinity. All right. Now, there's only one interval where this function is decreasing. That would be from right here down to here. So we'll say from negative 2.1 to positive 1.8, the function is decreasing. Remember, we're just listing the x values. Okay. Is 5 a relative or absolute maximum? So 1.5 is right here. Oh, excuse me, not 1.5. Is 5 a relative or absolute maximum? However, notice this arrow that tells us that this graph will continue to infinity. So the absolute maximum is infinity, but the relative maximum is 5. So it is a relative maximum. State the domain and range in set builder notation. State the domain and range in set builder notation. So domain for set builder notation, we use our brackets, then I'll put x such that, and we want to describe the x values here. So our smallest x value is at negative 4, and our largest x value is over here at infinity. So we know that all the x's are greater than negative 4. So the set of x's such that x is greater than negative 4. For the range, talk about the set of y's such that, let's look at our y values. Now, our smallest y value is down here at negative 4.9. Our largest y value is up here at infinity. So the set of all y's such that y, must be greater than or equal to negative 4.9. And that concludes today's lesson, Key Features and Attributes of Functions.